Hello everyone, welcome to my project presentation. Today I'll be demonstrating a simple but powerful system called a secure text encryption and decryption using Python cryptography library, particularly the Fernet model. The primary goal of the project is to protect a sensitive information during communication by converting readable text into secure encrypted text and then being able to decrypt it using a symmetric library. For running this project, we need different tool and technologies here, the Python programming language and cryptography library. At first, installing a Python, and after installing a Python, we need to verify the installation. And we need to go to the command prompt and we type python dash dash version. And for the installation of a cryptography, we need to do pip install cryptography in the command prompt. And for the verification, we need to go to the Python interpreter and run from cryptography.fornet import fornet. And we need to print if the cryptography.fornet and import fornet is successfully imported. In the result, you can see here the fornet model imported successfully. And after this environment is set up, we can code our we can coded our code in a Visual Studio Code. Now, before running this code, I'll tell you what is encryption and why this project. Encryption Encryption is the process of converting plain text into ciphertext and unreadable format to prevent unauthorized access. In a symmetric encryption, the same key is used for both encryption and decryption. I choose the Fernet symmetric encryption system from the cryptography library because it is highly secure, easy to implement, and widely used in a real world application. The project helps users securely share a message, password, or any other private information using a randomly generated key. Now, we are going to explaining the encryption function here. First, we generate a symmetric key using Fernet.generate key. This key must be saved because it requires a letter for decryption. Here, here we generate a symmetric key is equal to Fernet.generate key and we print the key here. So it must be saved because it is required later for decryption. Then the user input text is converted into byte. Here the user input key is converted into byte. And we need to create a format object using a key. We create a format object using a key here. Then we call a function. Then we call the encrypt function on the text byte. Finally, both the key and the encrypted text are printed for the user to copy. Here, the key and the encrypted text are printed for the user to copy. If someone wants to decrypt the message later, they need both the encrypted message and this key. And here the encrypted text and the both key and encrypted text are generated. And if we want further decryption, we need the key here. After encryption, we go through the decryption, the text. The function is used where the user already have the key and the encrypted text. The user must have the key and the encrypted text to decrypt it. So for this, convert the key and encrypted message into byte. We need to convert the key and encrypted message into byte and recreate the foreign object using the key. We need to convert the key and encrypted message into byte and recreate the foreign object using the key and use the decrypt method to decode the file. We need to use the decrypt method to decode the file, and after decode the it print the plain text. Now going through the live demonstration of this code, we are going to encrypt and decrypt the text here. At first, I'm going to encrypt the plain text here. My name is Rijal. Here, I am going to encrypt this plain text at first. For the encryption, we need to press 1 here, and we found the encrypted text here. Here we found this encrypted text, and we found the key here. So for further decryption, we need this key. So we keep this mm, key safely. So we keep this key here. Now for decryption, now for and we also can decrypt this encrypted text. So for decryption, we again run this code by this. Enter text you want to encrypt or decrypt. At this time, I want to decrypt this encrypted text. So I'm going to copy this, paste this encrypted text here, and I'm going to decrypt it. So for encryption, press 1, or for decryption, press 2. So I'm going to decrypt this encrypted text. So I'm going to press 2 here and enter a key that we must need to enter a key. So we keep this key safely in my documentation. So I attach this key here. Here I attach this key. Yeah, when I attach this key, that it's a, your decrypted text is my name is Rijal. So at first I enter the plain text for decryption, and I encrypt this plain text, and after encrypted I'm going to decrypt the encrypted text, and by using this key I decrypt this. Now, at last, this system can be used in a few useful way. It is great for sending passports or any sensitive text that you don't want to others to see. It can also help protect private message in a chat application and secure using credentials like usernames and password. The system uses Fernet encryption, which means it relies on AES 128 in CBC mode along with the HMAC authentication. It even includes a timestamp which help with the feature like message expiration or tracking when the data was encrypted. And the conclusion to sum up this project, so how can you protect sensitive information using a simple cryptographic techniques written in a Python. It's a good example of how even basic encryption can help make data safer. In future, I'd like to improve the project by allowing user to save and load encryption key from files. I also want to build a graphical user interface so that people can use the system without needing to touch the command line. And finally, I'd like to add a feature that lets message expire after the certain time. Thank you for watching my demonstration. I hope it was helpful and maybe you think about how to keep your data more secure.